everyone, I am Renu Sharma, Assistant Professor, EC Department. Today I am going to start with the next lecture of the subject, that is wireless and mobile communication, KC 076. Now, the topic of today's lecture is frequency reuse. So, in my previous lecture I have discussed that in wireless and mobile communication, every geographical area is divided into different cells. The shape of the cell will be an hexagonal. The reason I have told you earlier also, that it will going to provide the maximum coverage of the area, and it is not having any void, because if I consider this square or rectangle, triangle, it creates a void. Rectangle and square does not create, but it is not providing a greater coverage. The surface area of this hexagon is large as compared to the square and rectangle. Then in this case, like this is the first cell, this is second cell, this is third cell, every time it is not possible that set of frequencies will be allocated same to every cell. It is possible that this whatever set of frequencies, because set of pair of frequencies will be allocated, because it is a full duplex communication. One set of frequencies required to transfer from transmitter to receiver, that is base station to mobile. Another set of frequency will be required to transfer the information from mobile to base station. So, two set of frequencies are required. So, whatever set of frequencies I have allocated to this cell, every time it is not possible that it is using that frequency. Sometimes it is possible that it is ideal. So, in that case, that same set of frequencies will be allocated to another cell. So, I have to decide that which particular cell will going to use same set of frequencies. Maybe both are ideal at the same point of time, maybe both are using the same frequencies at the same point of time. One is using, other is not using, that is a very ideal situation. So, that is the frequency reuse concept. Next is the channel assignment strategies. However, I am assigning this set of frequencies, also known as channel. Whenever I am going to assign, what strategy I have to follow. So, that is a channel assignment strategy. Another is the interference and system capacity. So, this is a numerical part, or you can say a derivation part, that what is the interference that is calculated and what is the system capacity will be there. So, in this diagram it is clearly mentioned that why we have choose this hexagonal shape, why the inventor of this particular concept has used this hexagonal shape. Now, you can see when a circular shape cell will be considered. So, these are the void spaces, which means any subscriber or any person living in this area, here or here, it will not going to access the internet, it will not going to access the channel, it will not going to transfer, make a call. You can say it will not going to make a call from this particular place, because it is not covered under any of the cell. So, these are the missed areas. Second one is the triangular cell. Now, you can see that this space or the x is smaller than r, which means it is a non-uniform distribution, because there are two types of antennas which are installed, which is to be installed, like first one is the omnidirectional antenna, second one will be the directional antenna. So, omnidirectional antenna will be installed at the center of each cell. So, that means it is a center excited cell. Because it will going to transfer the information equally in every direction. But when we are talking about edge excited means at this edge or this edge or this edge, if I am talking about this triangle, then antennas has to be installed. So, it will not going to cover any area equally, because the distance of r and x. So, x is smaller than r, which means non-uniform distribution. Area of the triangle will be written as 1.3 r square. So, this is not accurate. Now, you can see that in case of this square also, it is having the non-uniform distribution, this distance is smaller than this one. So, center excited antenna will not work well in this case. Fourth one is the hexagonal cell, hexagonal shape, which is used. uniform distribution without overlap and without gap area. There is no gap area will be there, there is no overlapping which could appear, and also the area coverage is 2.6 r square, which is much greater as compared to the triangular and the square one. So, this is the concept of frequency reduced, that what shape has to be considered for each cell, so that it does not overlap and it does not provide any gap when two or more cells are connected next to each other. So, hexagonal cell shape is conceptual and is simplistic model of radio coverage for each base station. As the radiation from antenna is circular, thus there is a fading on edge of the triangle and the circular. In case of this omnidirectional antenna, the radiation pattern will be circular in nature, which means it will going to circulate equally in every direction. Let us say this particular antenna is installed at the center of triangle, then this will be the coverage, and you can see that this particular area will not be covered. In case of the square, in case of square also, and in case of directional antenna, its radiation pattern is somewhat like this one, which has it, this is the main lobe, this is the minor lobe, and these are the side lobes, means the wastage of energy will be there, the maximum energy will be concentrated in this direction and minimum energy will be concentrated in this direction. So, this is the radiation from the antenna, which is in this definition we are talking about the omnidirectional antenna, which has a radiation pattern circular in nature. So, in hexagon shape there is a lesser fading on the edges. When using hexagonal shaped cell, base station areas are depicted as either being in the center of the cell, which means this is centrally excited, and on the three edges of 6 cells or 6 vertices, then it is the edge excited cell. Now, for the central excited cell, omnidirectional antennas are used, and edge excited cells, sectored directional antennas are used. In case of omnidirectional antenna has its gain G is equals to 1. Every time we cannot use it, we have to divide the cell into different sectors. It can be a 60-degree sector, it can be a 120-degree sector. I am going to tell you how this will happen. Like this is one cell, and I am going to divide equally in this shape at the angle of 60 degrees. So, 1, 2, 3, 4, 5, 6. 60 degree have 6 sectors. And I am talking about 120 degree, so it is divided at an angle of 120 degree. This will be the case and this will be the case. Yes, this is not covered. This is a 120 degree case, this is 120 degree angle, this is 120 degree angle. So, 3 sectors will be there. So, depending on the population, like in suburban areas or open areas, the number lesser population is there. So, larger cell can work. So, sectoring can be used, like 120 degree sectoring will be there, or it does not require sectoring. But when the population is quite large and we require connectivity, then 60 degree sectoring will work, where each of the sector consists of larger number of users, they have their access to these users. So, this is omnidirectional antennas, and edge excited means this is sector directional antennas are used. So, this is 60 degree and 120 degree concept. And this diagram is going to give you a clear vision of what is center excited and what is edge excited. In case of centered excited, you can see that there is an omnidirectional antenna which is installed at the center of the cell. It will going to deliver the radiation equally in every direction to the edges, and inside the edge whatever user is present, it will going to deliver that data. In case of this edge excited, you can see that at the edge it is not a continuous edge, at this edge, this one and this one, the data will be, the antennas will be installed, and these are divided into sectored directional antennas will be there. It will going to radiate in this direction, this will going to radiate in this direction, this will going to radiate in this direction. So, this is the edge excited cell. Now we are heading towards frequency reuse concept. What are the different cells which are using same set of frequencies? It has to be calculated by a formula. So, the design process of selecting and allocating channel groups for all the cellular base station within a system is known as frequency reuse or frequency planning, which means the combination of cell will make up a cluster, and each of the cluster is using same set of frequencies. How many clusters has to be repeated, which will going to calculate the capacity of the system, which is denoted by C. C is equals to MKN. I am going to derive it in the next coming slides. So, these are the parameters that you have to calculate. So, frequency reuse distance, that is the minimum distance between co-channel cell required to keep the co-channel interference below the certain threshold. So, there will be interference will also occur. Let us say two cells are using same set of frequencies, then definitely the interference will going to occur. Why? Because it may be possible that both the cells are using the same set of frequencies at same time point of time. So, that causes an interference. So, each cellular base station is allocated a group of radio channels to be used within a small geographic area, that is cell. Base station of adjacent cells are assigned channel group which contains completely different channels than the neighboring cell. So, you can see in this diagram, like this is A, B, C, D, E, F, G up to means 7 cells are forming a cluster, then 7 same cells are there, 7 same cells are there which are using same set of frequencies. This is first cluster, this is second cluster, this is third cluster. So, 3 clusters are there and each cluster is having 7 cells. So, if n cells will collectively use the complete set of available frequencies, that is known as a cluster. Now, this slide is basically showing that how we are going to calculate this particular cluster. Now, the base station antennas are designed to achieve the desired coverage within a particular cell. By limiting the coverage of a cell, the same group of channels may be used to cover different cells, because if let us say pair of frequencies will be allocated, or you can say pair of channel will be allocated, a group of channel, same group of channels can be used by another cell. So, we have to decide that which particular cell has to use the same set of channel. So, after how many cells, 2 cells assign the same frequencies to use frequency reuse concept. So, consider a cellular system. From here onwards we are going to derive that which 2 particular cell has to use the same set of frequencies. So, consider a cellular system which has 2 S-duplex channels. S-duplex means that is total number of channels in a cluster, means both the combination we have to decide, because if it is having one pair, which means 2 channels are there, 2 pairs means 4 channels are there. So, if each cell is allocated a group of k channels, and if S channels are divided among n cells into unique and disjoint channel group, then the total number of available radio channels in a cluster can be given as S is equals to k n. K is S is nothing, it is a duplex channel. This is written, it is a duplex channel, n is number of cells and k is group of channel. And how you have to calculate n? N is having formula I square plus j square plus I j. How you have to decide this I and j? I means if I am going to discuss it, like this is the diagram. Let us say I have I is equals to 1 and j is equals to 2, then I have to calculate the value of n, that what is the number of cells which are included in a particular cluster. So, how it has to be possible, like this is 1 square, then 2 square, then 2. So, which means it will be makes up a 7. So, this means n is equals to 7 means in a single cluster there will be 7 cells which are incorporated. So, this will be the cluster, this is A, this is B, C, D, E, F and G, these are the clusters. So, this is making a cell. So, this is how I means if I is equals to 1, this is the center of the cell, I have to move 1 upward, then I have to take 60-degree rotation and have to move jump to 2 cells. So, this is first, this is second. So, whichever cell is present over here, it will, this cell and this cell is using the same set of frequencies. So, this is how you have to decide which will reduce the complexity, which will reduce the number of cells, and this is how you have to decide the particular cell. Then if the cluster is replicated m times, because in this diagram you can see that this particular cluster is repeated 3 times, 1, 2 and 3, the same cluster of 7 cells. So, m will be is equals to 3 in this case. The total duplex channels that can be used to measure a capacity is given as C is equals to ms or C is equals to mkn. Now, what is ms? Ms is nothing, it is number of times the channel is the cluster is repeated, and S is the duplex channel. We have calculated S is equals to Kn, then we can put C is equals to Mkn. So, this is the final formula of the capacity of a cellular system, which is directly proportional to the number of times the cluster is replicated in a fixed service area. So, this is the calculation of frequency reuse. Now, this is continued, like you can see that this is the factor n is called as a cluster size. Now, this diagram is showing that how you have to calculate the capacity. So, let total number of channel allocated for a cluster is S is equals to 395, let n is equals to 7, n is nothing, it is the number of cells in a cluster. It means that 395 by 7, that is 57 frequencies is possible, and average per cell to characterizing the frequency reuse. Then frequency reuse factors of a cellular system is given by 1 by n, since each cell within a cluster is only assigned 1 by n of the total available channel in the system. Now, what is n? N is nothing, it is the cluster size. It can be, it is written by I square plus j square plus I j, where I and j are nothing, these are the positive integers that you have to consider. This cannot be, this can be 0, but this cannot be negative. So, n can be any of the value. D is the distance between the center of two adjacent cells. R is the radius of a single cell. Capital D is the minimum distance between center of cells that use the same channels or frequency band, that is co-channel cell, that is denoted by capital D. Now, this is how you have to decide I and J. So, to find the nearest co-channel neighbors of a particular cell, one must do the following, like I have to move I cells along any chain of hexagon, like this is I cell will be there, then I have to turn 60-degree counterclockwise and then move j cells. So, this is counterclockwise 60-degree and then move j cells will be there. So, this is how you have to calculate this one. So, I is equals to 1, 2 and 3, j is equals to 1 and 2. So, which means that n is equals to 19, which means there will be 19 cells are there which will make up a single cluster. So, this is how you have to calculate the value of n. Now, next is the channel assignment strategy. How you have to assign the channel? It will be a fixed channel assignment and there will be a variable adjacent variable channel assignment, dynamic channel assignment will be there. So, for efficient utilization of radio spectrum, frequency reuse technique is used to achieve this following channel strategies. There are fixed channel assignment will be there, like each cell is allocated a predetermined set of voice channels. Then any call attempted within the cell can only be served by the unused channel in a particular cell. So, which means that let us say I have allocated fixed channel, fixed set of frequencies, and if another call will be raised. So, whatever channel is not in use, it will going to access that particular information, it will going to access that information, it is not going to borrow the channel if extra requirement is there. So, if all the channels in the cell are occupied, the call is dropped and the subscriber does not receive the service, which means that every time, because it is, since the assignment is fixed, channel assignment is fixed, it is not variable in nature, because every time it is possible that whatever set of frequencies you have allocated, it may be ideal, it may be possible that all the frequencies are in used, it may be possible that some frequencies are used, some are free. There is a situation that every set of frequencies will be is in used. So, several variation of fixed assignment exist. One approach is known as borrowing strategy. Borrowing strategy means I can borrow the set of frequencies from another user, so that it can be delivered, it can be used from another cell also. A cell is allowed to borrow channels from neighboring cell if all of its own channel are already occupied. So, the mobile switching center supervises such borrowing procedure and ensure that the borrowing is of the channel does not disrupt or interfere with any of the call in progress or donor in the donor cell. So, that is the concept of borrowing strategy, means it is assisted by MSC only, and it makes sure that whatever requirement is there, it will be fulfilled and it will not going to affect or interfere the call which is already in process in the donor cell. Now, next type of channel assignment is the dynamic channel assignment. Here the voice channels are not allocated to different cells permanently, because it is on the demand basis, because in some situation it is possible that the fixed channel, in case of fixed channel assignment, some of the cells are not in used, which is the wastage of that particular allotment. So, in that case dynamic channel assignment, instead each time call request is made, the serving base station request a channel from the MSC, that is the mobile switching center. Now, MSC then allocates a channel to request a call following an algorithm that takes into account the likelihood of future blocking within a cell, frequency of use of candidate channel, reuse distance of the channel, then there will be a cost function, real time data channel occupancy, traffic distribution and radio channel strength indicator. So, these are some of the parameters that you have to consider. The MSC allocates on the basis of these parameters. So, this increases the computational load on the system, but provides the advantage of increased channel utilization and decreased probability of blocked call. There are certain advantages and disadvantages of channel assignment. After reading this, you can consider, you can summarize what are the advantages. In case of fixed channel assignment, when I have fixed some set of frequencies for a particular use, it cannot be used by any other user, whether it is sitting ideal, these channel are sitting ideal, then it is just a wastage of that particular allotment. In case of dynamic channel assignment, it is on the basis of demand, it is assisted by MSC only. In case of fixed assignment, if I want to borrow some channel, it is also assisted by MSC. So, MSC is the main part which will going to allocate the channel. So, this is the dynamic channel assignment. Now, next is the interference and the system capacity. What are the sources of interference? Interference means whenever there is a call ongoing, then there will be a situation that the transmitter or receiver is moving in nature, because we are discussing the mobile communication. It is not always that both the users are fixed, means they can be moving in nature. So, which requires the allotment of signals from home location register to visitor location register. So, during that transferring, if it is not smooth, it is known as handoff procedure. If it is not smooth, then there will be call drop which will take place. So, that is a case of source of interference will be there. So, another mobile in the same cell will be there, a call in progress in a neighboring cell. This is also the possibility of the interference, co-channel interference, when same set of frequencies allocated to two cells. One is using for making a call and other is about to make a call, then there will be interference. Other base stations operating in the same frequency band will be there. Any non-cellular system which advertently leaks the energy into the cell frequency band will be there. So, that is a source of interference. Another is there that interference causes on voice channel causes crosstalk. Crosstalk means when mixing of information will be there. So, that is known as a crosstalk. where the subscriber hear interference in the background due to undesired transmission. So, on the control channels, interference leads to missed or blocked calls due to the errors in the digital signaling. So, that is the interference causes. This is co-channel interference. Co-channel interference means when two cells are using same set of channel, then that is known as, and that leads to interference, that is known as co-channel interference. So, unlike the thermal noise which can be overcome by increasing the signal to noise ratio, co-channel interference cannot be combated by simply increasing the carrier power of a transmitter, because an increased carrier transmit power increases the interference to neighboring co-channel cell. So, r is nothing, it is the radius of a cell, d is nothing, it is the distance between the center of the nearest co-channel cell. So, that is the co-channel interference concept. These are the references that you can consider for this particular topic. Thank you.